Hello everyone, welcome back to IGCSE Science Academy, where science made simple and clear. Dear viewers, today we are diving into the concept of buoyant force to better understand the science behind why things float and why they sink. As you can see on this poster, buoyancy isn't just a random occurrence, it's a specific upward push from fluid that keeps object afloat. We will explore how this force interacts with gravity and look at the Archimedes principle, which tells us that this force is actually equal to the weight of the fluid that the object displaces. So let's get down to the formal definition. What exactly is buoyant force? Buoyant force is the upward force exerted by a fluid on an object placed in it, whether that's a liquid or a gas, on any object placed within. The most important thing to remember is its direction. It's at opposite to the weight of the object, while gravity is busy pulling an object down towards the earth. The buoyant force is working to push it back up. Whether an object sinks or floats depends on entirely on the tug-of-war between these two opposite forces. Now this slide shows detailing the relationship between displaced water and upward force. We know what the force is. How do we measure how strong it is? That's where Archimedes' principle come in. This principle states that when an object is immersed in a fluid, it experiences an upward force exactly equal to the weight of the fluid it displaces. Think of it this way: when you put an object in water, it has to push some water out of its way to make room for itself. The water it pushes away then pushes back up on the object with a force equal to its own weight. Let's look at two simple examples to see this in action. A ship floats because it is massive and shaped to push out a huge amount of water. That large volume of displaced water creates a massive upward push, enough to keep the ship afloat. A coin sinks, on the other hand, because it is small and pushes out very little water. The weight of that tiny bit of water isn't enough to counteract the weight of the coin, so it sinks to the bottom. Now let's look at the specific conditions that allow an object to stay on the surface. An object floats based on two main factors. First, the factor must balance out. An object will float when the upward buoyant force is greater than or equal to the downward weight of the object. Second, we look at density. For an object to stay afloat, its overall density must be less than the density of the float it is in. A perfect example of this is a ship floating on water. Even though ships are made of heavy materials, their shape allows them to displace enough water to create the necessary buoyant force to overcome their weight. Here is a most common question: why ships float? After discussing the theory, let's look at a real-world marvel. Why do massive steel ships float, while a solid block of steel would sink instantly? A ship is a different story because of its design. There are four key principles at work here. Displacement through shape. The specific hollowed-out shape of a ship is designed to displace a massive volume of water. Second is creating upward force as the ship displaces. that water, it creates a powerful upward buoyant force. Third is the balancing act. If the force of this displaced bounce is greater than the downward pull of gravity on the ship's weight, the ship floats. Fourth is effective density. Even though steel itself is denser than water, the ship as a whole, which is filled with a lot of air, it's actually less dense than the water it sits in. As you can see in the diagram, a solid steel block sinks because it cannot displace enough water to match its weight, but the same amount of steel shaped into a hull will float perfectly. Now that we have seen why things float, let's look at the opposite scenario. Why do objects sink? An object will move downward through a fluid when its physical properties overcome the fluid resistance. There are two primary conditions that lead to sinking. The weight overpowers the lift. Sinking occurs when the downward weight of the object is greater than the upward buoyant force. In this case, the fluid cannot provide enough push to keep the object at the surface. Second is high density. Mathematically, an object will sink if the density of the object is greater than the density of the fluid it is placed in. A common example, think of a coin sinking in water. Even though a coin is small, it is made of metal that is much denser than water. Because it is small and solid, it pushes away very little water, meaning it only receives a tiny amount of buoyant force, not nearly enough to counteract its own weight. Now let's look at the specific variables that determine exactly how much push an object receives from a fluid. There are three primary factors that affect the magnitude of the buoyant force. First, the density of the fluid. The denser the fluid, the greater the buoyant force it provides. This is why it is much easier to float in the salty, dense water of the Dead Seas than in a freshwater swimming pool. Second, the volume of fluid displaced. As we learned from Archimedes' principle, the amount of space an object takes up in the water matters. The more fluid an object can push aside, the stronger the upward force will be. Number third is gravity. Since buoyancy is a reaction to the weight of the fluid being displaced, the local pull of gravity is final piece of the equation. Understanding these three factors allows scientists and engineers to predict exactly how any object from a small coin to a massive cargo ship will behave when it hits the water. Here are some exam tips. As we prepare for assessments on this topic, I want to leave you with these three essential exam tips to ensure you pick up every available mark. So tip 1, use a precise vocabulary when explaining why something stays up or goes down. Always explicitly mention buoyant force and density. Don't just say it floats, explain the forces at work. Tip 2, connect to the law. Use Archimedes' principle as the foundation for your explanation, mentioning that the upward force equals the weight of the fluid displaced shows a deep understanding of the physical involved. Leap 3, illustrate with examples. To earn full marks, always back up your theoretical statements with concrete examples, like the floating ship or the sinking coin we discussed earlier. This proves you can apply the science to the real world. We have learned today the buoyancy is a constant upward push from fluids that competes with gravity. Whether an object is a tiny coin or a massive cargo ship, its fate is determined by its density and the weight of water it displaces. Remember, if the buoyant force is at least equal to the weight, you are floating. If density and weight take the lead, you are sinking. Keep these principles and our exam tips in mind as you study. Thank you for your time, and I am happy to take any questions. Thank you for watching. If you found this breakdown of buoyant force helpful, don't forget to like and subscribe for more science lessons made simple. Stay curious, and I'll see you in the next video.